Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight, we'll drift into the strange and delicate world of quantum reality, a place where certainty loosens its grip, where particles hesitate before choosing who they want to be, and where the universe whispers in probabilities rather than commands. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if these gentle explorations bring you a sense of ease or curiosity. And whenever you're ready, feel free to leave a comment telling me where in the world you're listening from and what time it is for you right now. It's always a quiet joy to see the different corners of the planet gathering together here, each of us suspended in our own little moment of time. If you'd like, dim the lights a bit, or turn on a soft fan for a gentle background hum. Maybe set your phone aside or let it rest next to you and allow yourself this small sanctuary of stillness. And as we begin, there's nothing you need to hold on to. If your mind wanders, that's perfectly fine. Let it drift wherever it wants. We'll be here, moving gently at a pace that welcomes sleep just as much as curiosity. Now when you're ready, let us take our first quiet step into a universe made not of certainties, but of possibilities. If you imagine the world at its smallest scale, far smaller than dust, smaller than the lines in a fingerprint, smaller even than the patterns that cling to a single grain of pollen, you might expect things to be crisp and definite. Tiny beads bouncing and colliding, each with a firm position and a firm path. But the truth whispered by the quantum world is softer, stranger, and far more fluid. At this level, the universe doesn't speak in the language of is or is not. It speaks in maybes, in hazy possibilities, in gentle probabilities. Physicists call the mathematical description of this haze a wave function. It sounds technical, but we can think of it as something much simpler, a soft cloud of possibilities like morning fog drifting across a quiet field. The fog doesn't choose a single path, and it doesn't hold a single shape. It spreads, it trembles, it plays with light. In much the same way, the most fundamental pieces of reality don't commit to a single choice until the universe, or someone within it, asks a question. This is why, long ago, scientists realized they could no longer say, "The particle is here, moving there, with this speed." Instead, they had to say something more delicate, something the world had never needed before. The particle might be here, or there, or somewhere in between. Not because the particle is hiding, not because we're not clever enough to find it, but because at the deepest level, existence itself is a shimmering field of maybes, and certainty is only a brief visitor. Imagine standing on a beach at dawn. The waves haven't decided how strong they'll be yet. The tide is thinking about turning, but hasn't committed. The sky is still choosing what colours it wants to wear before the sun climbs out of the horizon. In that hour, everything feels possible. Nothing has locked itself into place. The quantum world is a little like that moment, stretched across the entire fabric of reality. Possibilities come first, decisions come later. For a long time, this idea made people uncomfortable. We humans like certainty. We like to say, "Here is the truth," and then place that truth neatly on a shelf where it can stay dust-free and reliable. But nature, as it turns out, is not concerned with tidy shelves. What looks like a crisp, solid world from afar becomes slippery and hesitant when you zoom in far enough. The closer you look, the more the universe wiggles between answers. This doesn't mean the world is chaotic. Chaos is noisy, aggressive, unstructured. Quantum uncertainty is nothing like that. It's soft, almost humble, like a gentle voice saying, "Let me keep some things open for a little while." This openness makes the world flexible. It allows atoms to bind into the shapes that form your body. It allows the sun to shine, because particles slip through improbable paths to ignite fusion. It allows chemistry to exist. Without this softness, without this shimmering uncertainty, the universe would be rigid, brittle, perhaps even lifeless. There's a quiet lesson hidden here too, one that sits somewhere between physics and the human heart. Sometimes when we hold on to a belief too tightly, it stops breathing. When we insist on knowing exactly who we are, we might unknowingly close the door on who we could become. When we revisit a memory again and again, pressing it for clarity, it shifts under our hands, reshaping itself with each inspection. In both physics and in life, the more rigidly we try to define something, the more it slips into something else. You can think of yourself at any moment as a kind of wave function, not fixed, not finished, but unfolding. A constellation of possibilities, some bright, some faint, all waiting for the right moment or question to take form. The roles you play, friend, child, dreamer, wanderer, aren't permanent identities. They are potential states, activated by context, shaped by interaction, shimmering with the same softness the quantum world has carried since the dawn of time. So when we say the universe is made of maybes, it's not just a scientific observation, it's a gentle truth about existence itself. The smallest things do not hurry to declare themselves, they wait, they drift, they leave room. And because of that room, stars can ignite, atoms can form, and life can choose its shape moment by moment. If you let the idea settle beside you, it brings a kind of calm. You don't need to know everything all at once. The universe itself doesn't. Possibility isn't a flaw. It's the quiet engine that keeps everything alive. And in this first step of our journey, we begin not with certainty, but with softness, trusting that the shimmering maybes beneath all things are not threats to understanding, but invitations. Whenever you're comfortable, we can gently continue from here, letting the next idea arrive in its own time, the way dawn slowly brightens a waiting sky. If you've ever tried to hold water in your hands, you'll know a quiet truth. The tighter you squeeze, the faster it slips away. Knowledge, especially in the quantum world, behaves with a similar kind of shyness. The more precisely you try to grasp one piece of truth, the more another slips from your reach. This idea is often called Heisenberg's uncertainty principle, but for our journey tonight, we can gently set aside the name and the mathematical expressions that usually accompany it. Instead, we can think of it as a soft rule of existence. Every answer arrives with a shadow, and every clarity costs another kind of clarity. At the smallest scales, where particles behave more like ripples of possibility than solid dots, there are certain pairs of properties that refuse to sit still long enough for us to capture both of them at once. Position and momentum are the most well-known pair. If you try to know exactly where something is, its tendency to move becomes hazy. If you try to know exactly how it is moving, its location becomes uncertain. It's not a failure of our tools, nor is it a limitation of our imagination. It is the universe's way of saying, you may observe, but you cannot own all truths at once. Imagine a firefly drifting through a dark garden. If you look gently, letting your eyes relax, you can see its soft movement as a glowing trail, a sense of direction, intention, drift. But if you snap your attention sharply to fix its exact spot in the air, the trail disappears. You know where it is, but not where it's going. And if you follow its path again, you lose the precise sense of where it just was. The firefly hasn't changed, only your way of looking has. The quantum world is full of these fireflies, flickering, drifting, making choices only as you begin to ask them questions. For a long time, people believed uncertainty was a kind of defect in our understanding. They imagined that if we simply built a more perfect microscope, or invented a gentler probe, or discovered a finer kind of measurement, we could peel away this fog completely and finally see the universe as it truly is, sharp and exact. But the more we learned, the more it became clear that uncertainty isn't a smudge on our lenses. It's woven into the fabric of existence. The haze is the truth. The fuzziness is the rule. And oddly enough, it is this softness that allows the universe to breathe, to form, to exist at all. Consider a string on a musical instrument. If you pluck it gently, the note lingers, warm and full. If you try to pin it down too tightly, pressing your fingers just a little too firmly, the note sharpens, tightens, sometimes even chokes. The beauty of the sound comes from the balance, the space allowed for vibration. In the same way, particles cannot sit still and be perfectly defined. They must be allowed a little wiggle, a little freedom, a little space to move. If their properties were fixed with absolute precision, the universe would collapse into a rigid, frozen grid with no room for creativity, no room for the delicate dance that gives rise to atoms, chemistry, warmth, and life. Heisenberg's insight offers something more than physics. It offers a lesson that feels almost like a soft hand placed on your shoulder. When we try too hard to define every part of ourselves, our identity, our goals, our purpose, we often lose the gentle possibilities that lie just outside the edges of certainty. We say, "I am this," and suddenly all the other things we could become fall away. We cling to a memory, repeating it endlessly, trying to lock it into one unchanging shape. But the more we examine it, the more it shifts, revealing edges we never saw before. Just as particles cannot hold still under scrutiny, the stories we tell about ourselves tremble under too much pressure. This doesn't mean we shouldn't seek clarity or understanding. It simply means that clarity comes with a cost, and sometimes the cost is worth paying. But the quantum world invites us to consider when it might be kinder to let certain truths remain open, when it might be gentler to hold our identities like loosely cupped hands instead of clenched fists. Certainty has weight, possibility has space, and both have their place. There's another side to this principle, one that feels almost like poetry. The very act of trying to know something precisely requires energy, a nudge, a disturbance, a whisper of interaction. When you try to pin down a particle's position, you must send something toward it. A photon of light, a touch of energy, a small ripple, and that touch changes the particle. The measurement is not passive. It is a meeting, a contact, a moment of influence. To see something is to change it. To understand something is to participate in its story. This idea, quietly tucked into the structure of reality, blurs the line between observer and observed. You cannot measure without touching. You cannot touch without altering. You cannot know without becoming part of the knowing. If you let that idea settle for a moment, it becomes deeply human. How many times have you tried to understand someone, only to realize that your presence changes the way they speak, stand, or share themselves? How many memories have changed simply because you revisited them? In trying to understand the world, we leave an imprint on it, sometimes small, sometimes profound, and the universe does the same to us. We might think of uncertainty as a crack in the glass, but it is closer to the curve of a bowl that holds water. It supports possibility. It shapes the space for events to happen. Without it, atoms could not settle into the gentle orbits that give matter its form. Without uncertainty, electrons would collapse inward and leave no room for chemistry. Without chemistry, there would be no breath, no weather, no oceans, no warmth. Uncertainty is not the opposite of order. It is a quieter kind of order, one that allows everything to exist not as fixed, rigid objects, but as living, evolving patterns. As you listen tonight, you don't need to memorize the terms or hold on to the scientific names. You don't need to follow every metaphor. All you need is the feeling this idea leaves behind, that the universe allows space for softness, for imperfections, for unanswered questions. And within that openness, life finds its room to move. If you let the thought drift a little, you might sense how this principle gently nudges us toward humility. The universe begins not with certainty, but with possibility, and in that soft beginning, we find a quiet reminder that we, too, can live without perfect answers, trusting that something beautiful can still emerge from the maybes that surround us. If the universe were built only from uncertainty, you might expect it to wobble like a badly balanced table. The smallest pieces drift and shimmer, their positions blurred, their movements hesitant, their identities soft around the edges, and yet, somehow, the world we wake up to each morning feels reliable. Your coffee cup stays where you left it. The floor doesn't dissolve beneath your feet. The chair holds your weight without pausing to reconsider. There is a kind of calm in the everyday, a steadiness that seems at odds with the shimmering, unpredictable nature of the quantum realm beneath it all. The bridge between these two worlds, one foggy and fluid, the other solid and dependable, is something physicists often call decoherence. It sounds intimidating, but its meaning is gentle. Decoherence is simply the process by which the soft, overlapping maybes of the quantum world settle into the clearer shapes of our everyday experience, the way mist slowly lifts to reveal the familiar edges of trees and rooftops below. Imagine for a moment a pond just after dawn. When the air is still, the surface of the water holds a perfect reflection of the sky. Soft pinks, sleepy blues, the faint outline of the rising sun. But the moment a breeze touches the water, or a bird dips its wing, or a leaf skims across the surface, that delicate reflection shatters into ripples. The clarity is gone. The picture dissolves into motion. Decoherence is the universe's version of that ripple-making breeze. It is the subtle disturbance created when the countless invisible interactions of the environment wash over a quantum system, dissolving its many possibilities into one familiar outcome. At the scale of atoms, particles exist as probability clouds, a haze of potential locations and states. But the moment they interact with their surroundings, even just slightly, that haze collapses into something with shape and direction. Not because the particle has made some grand decision, and not because the environment forces it to behave, but because the countless tiny interactions all whisper the same gentle message. Settle, choose, become. This settling allows the world to take form. It stitches the loose threads of possibility into the sturdy fabric of everyday reality. Without decoherence, matter would never hold its shape. Tables would not stay tables. Stones would not stay stones. Your breakfast would scatter into clouds of probability before it ever reached your hands. Decoherence is what allows the universe to write its story in ink rather than pencil, at least at the scales where we live and breathe. There is something poetic in this process. The quantum world is a place of openness, of multiplicity, of shimmering maybes. But as systems grow larger, their possibilities brush against one another, interfering, overlapping, weaving into patterns so dense that the delicate quantum fog becomes something steady, almost inevitable. It is as if the universe, in its smallest whispers, gives each particle a choice, but in its larger harmonies, invites them into a communal rhythm, one that feels like solidity, reliability, and calm. To understand this more intuitively, imagine a room full of people humming different notes at random. At first, it would sound chaotic, soft, scattered, indistinct. But if the people gradually begin humming in unison, even without planning to, the room fills with a single tone, a warm, collective vibration. Decoherence is a little like that spontaneous unison. Individual quantum notes blend into something that feels like one stable sound. There are no formulas needed here, only the recognition that when many possibilities interact, they begin to average out, smoothing themselves into something cohesive. And with enough interactions, enough whispers from the environment, enough breezes on the pond, quantum strangeness recedes into the background. Not gone, only quieted, like a dream whose details fade as the morning brightens. This idea can settle gently into our own lives as well. Just as particles at the smallest level experience an ocean of possibilities, our thoughts, choices and identities also shimmer with potential. Yet, when we move through the world, meeting people, making decisions, settling into roles, our once fluid possibilities begin to cohere into recognizable patterns. We become ourselves through interaction, much like particles settle into classical behaviors through their environment. And just as decoherence doesn't erase the underlying quantum truth, the possibilities remain there, humming beneath the surface. Our deeper potentials don't vanish either. They simply quiet down, becoming part of the hidden structure that supports who we appear to be. The person you are right now is one unfolding of many possible selves, shaped by countless small interactions, conversations, memories, kindnesses, disappointments, hopes you voiced, and dreams you kept to yourself. Each influence is like the faint ripple on the pond, softening the fog, giving shape to your story. Decoherence also reminds us that we do not exist in isolation. A particle collapses into a specific state not by its own will, but through contact with the world around it. We too become real to ourselves through others, through the way someone smiles when we enter a room, through the warmth of a shared moment, through the gentle recognition of being seen. Identity isn't carved out alone. It emerges from the soft, constant interplay between who we are and the world that touches us. In this way, the solidness we feel in our daily lives is less a permanent truth and more a beautifully maintained illusion, an illusion that nature creates through endless collaboration. The universe holds itself steady so we can walk through it without falling apart. And yet behind that steadiness lies a quiet truth. Everything is still shimmering underneath. Everything is still woven from probability and possibility, held together by the delicate threads of interactions too small for us to notice. If you let that idea rest within you for a moment, it brings a quiet sense of reassurance. The solid world beneath your feet may be built from uncertainties, but they are uncertainties that know how to work together. They create not chaos, but harmony, not confusion, but form. And in that harmony, we find the gentle bridge between the unpredictable quantum realm and the comforting stability of our waking lives. And as this thought continues its slow unfolding, it opens the way toward understanding how our questions, our perceptions, and our presence help shape the reality we experience, just as the environment shapes the world of quivering particles. If you've ever stood before a shelf of books and felt just for a moment that every story was waiting for you at once, you've touched a gentle shadow of the quantum world. Before you choose a book, before you reach for a spine or slide a volume from its place, every possible tale feels equally available. Mystery, romance, adventure, quiet reflections. You could step into any of them. But the moment your hand commits, the moment your fingers close around a single book, one story becomes real. All the others remain in the background, unwritten for now, quietly retreating into the maybes. At the quantum level, something very similar happens. The properties of particles, where they are, how they spin, what path they take, do not sit on the shelves of reality waiting to be discovered. They don't exist as neat, labelled facts. They begin as possibilities, as overlapping maybes, as shimmering outlines of what could be. And only when a question is asked, only when a measurement is made, does a single answer step forward and solidify. This is the heart of what physicists call the measurement problem, though the phrase makes it sound far more technical than it needs to be. At its core, it asks a surprisingly poetic question. When does a possibility become a fact? What nudges a particle from a cloud of potential outcomes into one specific result? And why does the universe seem to wait until we ask before telling us what is true? To ease into this idea, imagine walking into a room lit only by moonlight. In the dim glow, the shapes of objects blend together. A chair becomes a heap of shadows. A coat on a hook looks like a person standing still. The dress emerges into the wall. Nothing is sharp or definite, but the moment you flip on a lamp, the scene reorganizes itself. The chair becomes a chair again. The coat becomes a coat. The shadows retreat. In a way, your act of illuminating the room didn't just reveal the objects, it stabilized them. Quantum measurement feels much like switching on that light. Before you observe a particle, it doesn't occupy one precise position or one precise state. It has a whole landscape of allowed possibilities, spread out like brushstrokes on a canvas. But the moment you look, when you bring your attention, your interaction, your measurement, the canvas pulls itself into a single line, sharper and more specific than anything that existed before. What makes this idea especially strange is that particles do not seem to carry hidden instructions about which answer they should give. There is nothing inside them saying, if asked about spin in this direction, answer up. If asked in another direction, answer sideways. Instead, the universe waits for the question and forms the answer in that instant. The response depends not only on the particle itself, but on the context of the question, the direction, the method, the kind of measurement. It is as if reality speaks different truths depending on the language you choose to ask in. This isn't metaphor. It is woven into experiments again and again. When scientists measure one property, they get one answer. When they measure another, even if done a moment later, the particle behaves as if it had no stored memory of the first result. It responds anew, shaped by the nature of the new question. The universe, in its smallest details, behaves like a storyteller who tailors the tale to the listener, crafting the narrative moment by moment rather than reciting from a fixed script. And this gives us a deeply unsettling, yet beautiful insight. The world is not simply revealed through observation, it is in some sense created through it. Imagine asking someone, "Who are you?" The question might feel too large, too vague, but suppose you try again with more detail. Who are you when you're with your closest friends? Or who are you when you're alone, at night? Or who are you when you hear a song that breaks your heart? Each question draws out a different truth, not because the person has one hidden essence, but because identity is a constellation of possibilities. Context draws out the stars that respond. Similarly, a particle has no single set of properties waiting to be uncovered. It is a constellation of potential states, and the question you ask determines which star lights up. This perspective can feel uncomfortable at first. We like to imagine the universe as a warehouse of facts, with every object waiting neatly on a shelf, labelled and ready to be found. But the quantum world whispers something softer. Reality is participatory. You don't stand outside it, observing from a safe and separate place. You're woven into its unfolding. Your questions matter, not just for understanding, but for the very shape the answer takes. If you let that sink in, there is something profoundly human here. We often imagine ourselves as detached observers of our own lives, trying to find the truth as if it were hidden somewhere behind a door or beneath a stone. But perhaps the truth of our experience is also formed by the questions we ask. When you look for kindness, you begin to notice it. When you search for meaning, small moments reveal significance. When you ask harsh questions, "What is wrong with me?" or "Why am I not enough?" the answers shape themselves around the tone of the inquiry. Reality, both personal and physical, bends toward the questions that guide your attention. This doesn't mean we create the universe with our thoughts. The world is not a fragile dream we can rearrange at will, but our role in it is more intimate than we once believed. We are not merely witnesses, we are participants, co-authors, characters who help shape the story by the questions we choose to ask, the attention we bring to a moment, the curiosity we dare to follow. If you picture the universe as a grand, shimmering landscape of potential, then measurement, the act of observing, becomes a quiet way of stepping into that landscape and leaving footprints. Each footprint marks one path out of many, one reality chosen from an entire field of possibilities. and though we cannot see the paths we didn't take, we can sense them as gentle echoes, the lingering maybes that surround every choice. As we drift further into this idea, we'll see how other layers of the universe, fields, vacuums, time itself, continue this pattern of shared authorship. But before we reach them, it helps to rest with this simple, delicate truth. Reality is not a fixed story waiting to be read. It is a living narrative, shaped by interaction, sculpted by questions, and illuminated one moment at a time by the soft light of attention. There are moments in science that feel less like discoveries and more like someone gently lifting a curtain to reveal a secret the universe had been keeping for ages. The double-slit experiment is one of those moments, a small, simple setup that somehow manages to touch the deepest layers of reality. It requires no massive observatory, no towering particle accelerator, just a source of tiny particles, 2 narrow openings, and a screen. And yet, in this humble arrangement, the universe whispers something that can undo everything we thought we knew about matter, observation, and the quiet conversation between possibility and fact. Imagine standing beside a small pond on a still evening. You toss 2 pebbles into the water, one after the other. As they fall, 2 sets of ripples expand across the surface, meeting, merging, and weaving into one another. Where the ripples overlap in gentle agreement, the water rises into brighter peaks. Where they cancel, the surface smooths into calm troughs. This graceful dance is called interference, the signature of waves interacting. Now imagine something very different. Tossing tiny marbles through 2 windows in a wall. The marbles don't ripple or weave. They choose one window or the other, hitting the ground behind in simple, predictable patterns. No interference, no mystery. For centuries that was how we imagined particles behaved, like little marbles, solid, definite, choosing one path, not 2. But when physicists sent electrons, those tiny pieces of matter, toward 2 slits, something astonishing happened. Instead of forming 2 simple piles behind the slits, the electrons created an interference pattern, the same pattern you would see from overlapping waves on a pond. It was as if each electron passed through both slits at once, rippling like water, exploring 2 possibilities at the same time, touching both paths before deciding where to land. And the magic deepens. Even when electrons were sent one at a time, so slowly that no 2 could possibly interfere with each other, the pattern still emerged. Each electron behaved like a solitary wave, folding and unfolding through both slits, interfering with itself. The result was not a collection of random dots, but a quiet, orderly pattern of peaks and spaces, as if the universe were sketching a hidden rhythm into the screen. But then came the strangest part of all. When scientists placed a detector at the slits to find out which path an electron took, the interference vanished. The soft wave-like behaviour dissolved. The electrons no longer drew delicate patterns. Instead, they behaved like marbles again, choosing one slit or the other, leaving behind 2 simple clusters. The act of watching, even gently, even without touching, changed the outcome entirely. Without observation, electrons wandered through both slits, as if sampling the entire landscape of possibility. With observation, they collapsed into a single, definite path. The universe seemed to ask us a question. What kind of answer do you want? A wave or a particle? And somehow, it tailored its behaviour to our attention. To soften this idea, further imagine watching a child who hasn't noticed you're there. Left alone, they play freely, muttering, improvising, creating little worlds with toys and scraps and clouds of imagination. But the moment they sense they're being watched, their behaviour shifts. They become more deliberate, more linear, more self-conscious. A quantum particle, in its own mysterious way, behaves something like that child, free and fluid when unobserved, structured and specific under the spotlight of measurement, The double-slit experiment invites us into a truth that refuses to be tamed. The world is not made of tiny billiard balls, each with predetermined paths. Instead, it is made of delicate probability waves that explore multiple possibilities, blending softly until attention causes them to settle. Reality is not a rigid stage where events happen independently of us. It is something more intimate, something that responds, shifts, and reshapes itself according to the questions we ask and the way we choose to look. We can feel this in our lives too, in quieter moments. Consider how the mood of a room changes depending on the attention within it. A conversation can unfold naturally when no one is judging it, but stiffen when someone suddenly scrutinizes every word. Artists know that creativity flows best when watched softly, but falters under harsh observation. Even our own thoughts behave differently when we try to inspect them too closely. They fidget, blur, or slip away like fish beneath water. The double-slit experiment takes this human intuition and shows us that it is not merely psychological. It is a principle written into the architecture of the cosmos. Observation is not passive, it is participatory. We don't just witness the world, we help shape the form it takes. This does not mean consciousness creates reality in the sense of pure imagination, but it does mean that interaction, measurements, contacts, questions, is woven into the way the universe chooses its outcomes. It means that the world is not merely a thing happening to us, it is a relationship unfolding with us. And if particles can move through two slits at once, exploring multiple paths before choosing one, perhaps our own lives too carry more possibilities than the single trail we walk each day. Before choices are made, we contain a soft cluster of directions, dreams, hesitations, potential futures glowing like faint ripples on a pond. Only when life's detector shines, through a decision, a moment of clarity, a change in perspective, do our paths collapse into something definite. The double-slit experiment doesn't tell us how everything works. Instead, it tells us that the world is more subtle than we ever imagined. Beneath the surface of certainty lies a shimmering field of alternate rhythms, erased or revealed depending on the gentleness of our gaze. And if we let that idea settle, it brings a kind of peace. We don't always need to choose sharply or understand fully. Sometimes it is enough to recognize that life, like electrons, holds a quiet multiplicity, and that the way we look can change the story that arrives. As this thought begins to soften into stillness, it gently prepares us for an even deeper mystery. How our attention doesn't just influence particles, but also shapes the landscape of fields and vacuums that hold the universe together. There is a quiet moment that happens before you notice something, a moment in which the world is still undecided, waiting, almost holding its breath. You might walk past a flower without seeing it, and in that instant it is simply part of the background, a gentle blur of colour along the edge of your awareness. But the moment you turn your gaze toward it, the moment your mind says, "I want to understand this," the flower emerges with texture and shape. You notice the folds of its petals, the faint shimmer of dew, the way the morning light rests on its edges. Nothing physical has changed, and yet everything about your experience is different. Your attention has created a kind of clarity. In quantum physics, a similar shift occurs. The universe does not present itself as a complete, fully formed picture waiting for us to walk through it like a museum. Instead, it offers possibilities, soft, overlapping, shimmering possibilities. And the questions we ask, the measurements we make, the angle from which we observe, all play a role in determining which of those possibilities steps forward into the world we experience. This doesn't mean that consciousness alone conjures reality into existence. The universe is not a dream that appears only when we imagine it. But it does mean that what we choose to look for influences what we find. The world reacts to the framework of the question. It answers in the language we use to ask. And in this subtle relationship between attention and outcome, reality becomes something collaborative, an interaction rather than a solitary truth. To ease into this idea, imagine a painter sitting before a blank canvas. They have a palette of countless colours, brushes of different shapes, and a mind full of emotions, memories, impressions. They could paint a river or a sky, a still life or a face, a storm or a garden. The canvas itself holds all the potential, but nothing becomes real until the painter chooses a brush, mixes a colour, and makes the first stroke. The painting is not hidden in the canvas, it emerges through choice and attention. In the quantum world, a particle is like that canvas, carrying within it a spectrum of possible outcomes. A measurement is the painter's first brushstroke. It selects which aspect becomes actual. The rest remain in the background like unchosen colours waiting quietly on the palette. Even the orientation of a measurement shapes the result. Ask about a particle's position, and it gives you a place. Ask about its momentum, and it gives you a motion. Ask about its spin in one direction, and it settles into an answer that fits your question. Ask about its spin in another direction, and it responds anew. The particle is not a locked box of pre-written facts. It is more like a versatile storyteller that adapts its narrative to the listener. This idea, known in physics as contextuality, can be softened into something deeply intuitive. Think of a person you know well. If you ask them about their happiest memory, they become warm, expansive. Their voice changes, their posture eases, their eyes brighten. Ask them instead about a difficult time, and the change is immediate. A different truth emerges, shaped not by deceit, but by the way the question frames the mind. Neither answer is the whole story. Each is a facet illuminated by attention. In a similar way, quantum systems reveal different truths depending on how we choose to observe them. Reality is not a rigid sculpture. It is more like an instrument waiting to be played. The music it produces depends on where we place our fingers, how strongly we pluck the strings, and which notes we listen for. This doesn't violate objectivity, it expands it. The object we measure is real, and so is the outcome, but neither is independent of the way we choose to engage with it. We and the universe meet halfway, our questions forming one part of the conversation, the quantum system responding with the other. To bring this into our daily lives, consider how our own perceptions shape the world we see. If you enter a room looking for flaws, they reveal themselves quickly. A crooked picture frame, a stain on the wall, a crumb on the table. But walk in with gratitude on your mind and suddenly the room feels warm, inviting. The same environment, observed through different questions, provides different answers. Even our memories behave this way. A moment from childhood might feel joyful when viewed with affection, or bittersweet when viewed through the lens of loss. The memory hasn't changed. The question has. Attention is not a force that imposes itself. It is a gentle filter that colours experience. And at the most fundamental level of physics, this filtering process becomes more than a metaphor. It becomes a principle. What we choose to measure opens one door and closes another. What we choose to look for shapes the outcome we observe. There is something comforting in this. It means we are not passive passengers drifting through a fixed universe. We are participants, influencing the reality we encounter, even in subtle and quiet ways. Our attention, where we place it, how we offer it, the softness or sharpness of our gaze, matters. If you picture reality as a vast ocean of possible currents, then attention is the small rudder that helps guide us through it. Not with force, not with dominance, but with a kind of gentle steering. A shift in intention here, a question there, and suddenly the landscape changes, revealing new textures, new patterns, new meanings. Quantum. Physics gives this idea a foundation, but it doesn't belong only to physics. It belongs to anyone who has ever felt the power of focus. Anyone who has noticed that when they stop looking for reasons to worry, the world becomes a little calmer. Anyone who has realised that a small moment of curiosity can make a familiar place feel new again. Attention is creation, not because it fabricates the world, but because it helps select which of the many possible facets the world shows us. It is the meeting of your curiosity and the universe's offerings, a soft collaboration that shapes the story you receive. And as we let this idea settle, it gently leads us toward the next layer of our journey, the vast invisible oceans of fields that ripple beneath everything we see, and the vacuum that is not empty at all, but alive with quiet motion. If you imagine peeling back the layers of the world, brushing aside the textures of wood and skin, the colours of leaves, the weight of stone, the brightness of stars, you might expect to find a final layer underneath it all, a bedrock of tiny particles, a foundation made of unbreakable pieces, something solid, something you could point to and say, this is the stuff everything is made of. But the universe has a gentler, more surprising truth. When you strip away the familiar surfaces of matter, you don't arrive at a pile of beads or marbles. You arrive at something far more fluid, a set of vast invisible fields stretching across all of space. Not fields like farms or meadows, but continuous rippling presences, oceans without edges, filling every corner of reality. And what we call particles are not things floating inside these fields. They are simply small, temporary ripples, like raindrops striking a still pond, or the vibrating note on a violin string when it's gently plucked. Every kind of particle we know corresponds to a particular field. There is an electron field spread across the entire universe, and when this field ripples in the right way, you get an electron. There is a photon field, and when it trembles, you get a particle of light. There are fields for quarks, fields for neutrinos, fields for the forces that bind the cosmos together. Each of them fills all of space. Each of them hums quietly in the background, like the low and constant note of a distant choir. This means something almost too strange to believe. The electron in your fingertip and the electron in a distant star are not separate objects made from separate material. They are ripples on the same underlying field. They are connected not by distance, but by belonging to the same ocean. Space simply arranges its vibrations in different places, like wind shaping different waves on the same sea. To bring this into a gentler image, imagine a calm lake at dawn. The surface is glassy and still. But if you tap the water with your finger, a ripple spreads outward. One small wave among many possible waves. The ripple isn't a separate object, it's a temporary pattern in the water itself, and when the ripple fades, the lake remains unchanged in its essence. In the same way, when a particle appears, it's a temporary ripple in its field. When it disappears, the field remains steady and ever-present. This realization softens the idea of things. It suggests that matter is less like building blocks and more like music, patterns emerging from deeper structures, notes rising and falling from instruments that never stop playing. And yet, within these fields, a certain rule quietly keeps order. It's sometimes called the rule of forbidden sameness, and we can think of it like this. Certain ripples cannot sit in exactly the same pattern at exactly the same time. Much like two people cannot comfortably occupy the same chair, certain vibrations refuse to overlap perfectly. This quiet rule is the reason your chair feels solid beneath you. It's the reason your hand cannot pass through a wall. It's the reason matter holds its shape. Solidity in this sense is not an inherent property. It is a graceful agreement between waves, an arrangement that says, this pattern is already taken. You must find another. If you look around your room right now, everything you see, every surface, every object, is the outcome of these arrangements. Countless fields humming with tiny ripples, none of which are truly separate from the ocean beneath them. This perspective brings a kind of peaceful coherence to the world. It tells us that matter is not a mosaic of disconnected parts, but a unified, continuous fabric. We are not made of isolated pieces that drift through empty space. We are made of ripples in fields that stretch from one end of the cosmos to the other. The boundary between you and the universe begins to blur. Your body is not a separate object. It is a region of space where certain fields have taken on particular rhythms. There is also something tender in the idea that a ripple alone cannot tell its own story. A wave on a lake carries the memory of the surface beneath it, the wind that shaped it, the stone that disturbed it. In the same way, every particle carries the imprint of its field, the silent backdrop that gives it meaning. No particle exists independently. It is always an expression of something deeper, something continuous. Even the forces we experience, electricity, magnetism, the strong interactions that hold the nucleus of atoms together, are not separate mechanisms. They are simply different ways these fields weave into one another. Instead of thinking of forces as invisible hands pushing and pulling, we can think of them as patterns in the ocean, rising and fading, intertwining like the currents beneath a river's surface. And then there is the vacuum, the state where these fields are as quiet as they can possibly be. It sounds like emptiness, but quantum physics offers a soft correction. Even at their quietest, fields never truly rest. They tremble with the faintest fluctuations, the gentlest murmurs, as if whispering that potential never fully disappears. The vacuum is not a void. It is a lullaby sung by fields waiting for the next ripple to begin. To bring this closer to our lives, think of the way our sense of self arises. We often imagine ourselves as solid, unchanging cores, fixed identities like statues carved in stone. But if we look closer, we begin to see something more fluid. Our thoughts, emotions, and memories rise and fall like ripples. Our identities shift with new experiences. The self becomes less like a thing and more like a pattern, a ripple formed within a deeper continuity of consciousness and connection. In this way, the fields of physics offer a metaphor for our own inner landscape. Beneath all the changing ripples, something continuous hums quietly, carrying the potential for new patterns to emerge. As this idea settles gently inside you, it begins to open the path toward the next layer of our exploration, the vacuum itself, which appears empty but is alive with secrets, energy, and the breathtaking possibility that nothingness is never truly nothing. If you close your eyes for a moment and imagine nothing, you might picture a quiet darkness, an empty room with no sounds, no movement, no light, no presence at all. A place where every ripple has faded, every whisper has fallen silent, and every possibility has gone to sleep. For a long time, scientists imagined something similar when they spoke of the vacuum, a perfect void, the cosmic equivalent of an untouched stillness. But the universe, in its gentle way, offers us a softer correction. The vacuum, the state of space with no particles, no heat, no motion, turns out not to be empty at all. Instead, it behaves like a resting instrument that never stops humming, even in perfect stillness. At the deepest level, where fields stretch across all of existence like invisible oceans, there is no such thing as silence. There is always a faint tremble, a subtle vibration, a quiet song the universe never stops singing. This whisper is sometimes called zero-point energy, a poetic way of saying that even at their lowest possible energy, quantum fields retain a small, irreducible shimmer. Like a plucked violin string that continues to vibrate long after the music fades, the universe cannot quite settle into perfect rest. It seems to prefer a gentle humming over absolute stillness, as if creation itself requires a little motion to remain alive. These tiny oscillations give rise to something even stranger, the brief appearance of virtual particles, tiny flickers of existence that come and go so quickly they almost feel like daydreams. These transient sparks rise out of the vacuum and slip back in before they can be fully noticed, borrowing a bit of energy from the fields and returning it so quickly that the universe allows the borrowing to continue uninterrupted forever. They are like fireflies that flicker only in the corner of your eye, vanishing the moment you turn your head. To soften the image, imagine watching heat shimmer above a road on a hot afternoon. The air seems to ripple, as though invisible shapes are rising and falling. You never capture one of those shapes in your hand. You never see a single ripple form into something solid. But you know the motion is there, flickering at the edge of perception. The vacuum is full of such shimmer, ripples with no permanent shape, motion without form. This might sound abstract, but the effects of these ghost-like flickers are real enough to measure. One of the gentlest demonstrations comes from what physicists call the Casimir effect, though we can think of it in simpler terms. When two objects are placed extremely close together, close enough that only the more delicate ripples can fit between them, the vacuum pushes them toward each other. Imagine two boats on a lake drawn together not by any visible rope, but because the waves around them nudge them closer. The vacuum does the same, using tiny ripples that never fully disappear. Even the colours of atoms carry the signature of these invisible vibrations. The faint glow emitted by hydrogen, the soft lines in a star's spectrum, the delicate behaviour of electrons around a nucleus. All of these hold subtle shifts caused by the vacuum's tremble. In everyday life we never notice them, but they are always there, woven into the fabric of every moment, like a ghost melody running beneath the main song. And then there is the vacuum's most astonishing secret. Its quiet energy helps shape the expansion of the entire cosmos. As space stretches, the restless hum of the vacuum fills each new region. It does not thin out, it does not fade, it remains steady, as though the universe paints its growth on a canvas woven from soft, persistent motion. This energy is believed to contribute to the gentle acceleration of cosmic expansion, a cosmic push, like a breeze that never stops blowing. Even so, the vacuum's energy is a mystery. When physicists try to calculate how strong this background hum should be, the numbers grow wildly large, as if the vacuum should roar with unimaginable force. But the universe we observe stretches calmly, slowly, almost tenderly. It's as though we hear only a whisper where theory predicts a storm. This mismatch, this strange gap between thunderous expectation and quiet reality, is one of the most perplexing puzzles in physics, like hearing a symphony and discovering the sheet music predicts an explosion. But for our slow journey tonight, we don't need to solve this puzzle. It's enough to recognize the poetry in it, that emptiness is never truly empty, that silence carries a hidden strength, that the quietest places can hold the most intricate secrets. When we think of emptiness in our own lives, moments where nothing seems to happen, or days that feel like pauses rather than progress, it's tempting to imagine those spaces as wasted or hollow. But the quantum vacuum offers another lens. It shows us that stillness is rarely still. Beneath the surface of quiet moments, small shifts, new potentials, and unseen transformations continue to unfold. Nothingness becomes a place of preparation, a cradle of subtle beginnings. In the same way, we often carry inner stillness without recognizing it. When we rest, when we pause, when we let the mind gently unfocus, there are background processes, dreaming, healing, integrating, softening, that continue even when we feel empty. Our inner vacuum hums with quiet energy, shaping who we become in ways we might never notice directly. This understanding also softens our view of the universe itself. Instead of imagining space as a vast, cold emptiness, we can imagine it as a subtle, breathing presence, a backdrop woven from gentle motion. Every star, every atom, every heartbeat rises from this subtle foundation. We are, in a way, the ripples formed on top of the vacuum's quiet sea. And as this idea settles in, we begin to glimpse how these ever-present fields shape not only the particles within them, but the vacuum beneath them. A place that seems empty, but is in fact alive with restless possibility. A place that holds the next ripple, the next glow, the next moment, waiting to unfold. Tonight, the vacuum becomes not an absence, but a soft, ever-singing presence, a reminder that even in stillness the universe continues to hum. If you imagine the universe at its earliest moments, not as a place but as a feeling, it might resemble the hush before a storm. Everything was hot, bright, and extraordinarily fluid. Particles raced wildly, fields trembled without rest, and nothing held its shape for more than a heartbeat. It was a world without anchors, without weight, without distinctions, a world where everything behaved like light, swift, restless, and unbound. But beneath that chaos lay something remarkable, a field waiting to define the way the universe would eventually settle. This field, spread gently across all of space, is sometimes called the Higgs field. Yet tonight, instead of picturing equations or diagrams, we can imagine it as a kind of invisible atmosphere, a soft cosmic fog that fills the universe with a quiet resistance. Objects moving through it do not glide effortlessly. They feel a subtle drag, the way your hand feels resistance when moving through water. That gentle drag is what we interpret as mass. To feel the idea more intuitively, imagine walking through a room filled with dancers. In some areas, the dancers are still, and you slip through easily. In others, they are moving in slow, dense clusters, and you feel yourself pulled into their rhythm. The Higgs field is a bit like that invisible crowd. Some particles pass through barely noticed. Others are caught gently by the movement, and acquire weight, like travellers stepping into a slow-moving tide. Before this field settled into its present form, particles were weightless, unable to form stable structures, unable to gather into atoms, unable to craft the matter that fills your everyday life. But as the universe cooled, the Higgs field underwent a quiet transformation, like molten glass suddenly deciding to harden into a new shape. And once it chose that shape, the universe changed forever. This transformation is often described as a phase transition, though we can think of it more gently, as the moment water decides to freeze into ice or steam softens into rain. The shift was gradual but decisive, and as the Higgs field settled, different particles began to feel different amounts of resistance. Some slowed down quite a lot, growing heavy and grounded. Others barely noticed the change and remained nimble and light. This differentiation, this cosmic sorting, gave the universe its texture. In that moment, patterns that had once been impossible became inevitable. Atoms could form because electrons suddenly had enough weight to orbit rather than fly away. Nuclei could hold together. Structure could begin. In a real sense, the Higgs field sculpted the universe into something that could last. Without it, stars would never ignite, planets would never form, life, in all its delicate layers, would remain just a whisper of potential. The Higgs field also carries a deeper truth about reality. The laws of the universe arise not from rigid commandments, but from the way fields choose to settle. The Higgs field could have crystallized into a different pattern with different strengths, and if it had, the universe would be unrecognizable. Perhaps heavier particles wouldn't exist. Perhaps atoms would never bind. Perhaps gravity and light would dance in different proportions. Our reality is not the only possible script, it's simply the one written by the particular shape the Higgs field decided to take. And this idea, when softened, becomes something beautifully human. We often think of our identities as fixed. I am this and not that. But beneath those statements lie patterns that took shape gradually. Habits, memories, relationships, and choices that settled over time to form what feels like a self. We too carry invisible fields inside us. The tone of our childhood, the music of our culture, the warmth or coolness of the environments that shaped us, all act as fields through which we move, acquiring the traits and tendencies that become our version of mass. There are moments in life when those inner fields shift suddenly, like water freezing or melting. A loss, a discovery, a quiet realization, a moment of courage, and afterward we find ourselves moving differently through the world, shaped by a transformation that others cannot always see, just as the Higgs field's transformation shaped reality itself. There is also a softer, more mysterious idea tied to the field. Even though the Higgs field today rests in a stable form, physicists believe it may not be the only possible resting place. It sits in a gentle valley of energy, but far above it, almost unimaginably far, lies the possibility of another valley, another resting place, another configuration. If the field ever shifted into that deeper valley, the universe would be rewritten, not destroyed by fire or force, but quietly restructured from the inside out. New laws, new possibilities, a new reality, arising from a simple change in the field's shape. But this is not something to fear. The universe moves slowly with immense patience, and the Higgs field has remained settled for billions of years. Instead of worry, this idea offers a kind of peace. Even the foundations of reality have room to breathe. Even the deepest fields carry the potential for change. Nothing is so fixed that it cannot shift. Nothing is so complete that it cannot evolve. The Higgs field teaches us that reality does not come from unchangeable particles, but from patterns of relationship, fields humming across space, offering resistance, shaping motion, sculpting existence. And when we look at ourselves with the same softness, we can begin to appreciate how our own identities emerge from context, interaction, and the invisible atmospheres of our lives. As the meaning slowly folds itself into stillness, it opens a gentle doorway toward the next part of our journey, the nature of time itself, and how it bends, freezes, or reverses under the quiet influence of quantum rules. If you imagine time as a straight road, smooth, predictable, stretching confidently from a clear beginning toward a definite end, you wouldn't be alone. Most of our days feel like that. Morning follows night, footsteps follow footsteps, and memories arrange themselves in lines that seem to march forward without hesitation. But beneath this gentle surface, at the scale where particles flicker and fields breathe, time behaves with a kind of softness that defies straight lines. It bends, it folds, it hesitates. Sometimes, it even seems to loop back on itself, like ripples drifting upstream before settling into the current again. One of the strangest places this happens is with virtual particles, those brief flickers that rise from the vacuum like sparks from a quiet fire. They pop into existence, borrow a bit of energy, which the universe allows as long as it's returned quickly, and then dissolve again before anyone can truly catch them. These tiny borrowings are not random. They form the background hum of existence, the constant shimmer beneath every atom and field, and in their hurried lives something curious happens. Cause and effect begin to blur. Imagine dropping a pebble into a pond. You expect the ripples to spread after the pebble touches the water. But at the quantum scale, there are moments where the ripples appear a heartbeat before the pebble lands, soft hints of motion that seem to anticipate the event rather than respond to it. It isn't that the universe breaks its rules. It's simply that the rules, when softened to their finest texture, allow small fluctuations to momentarily drift out of sequence, like notes in a melody played with a hint of improvisation. This gentle bending of time's arrow becomes even more intriguing when we explore the way certain particles can be interpreted. When a particle of light interacts with empty space, or when an electron flirts with a vacuum's trembling energy, the mathematics used to describe its motion often allow for paths that seem to slip backward in time. Instead of pushing the image of equations into our ears, we can give it a softer framing. Imagine watching a bird through a window. It swoops across your field of vision, graceful and quick, and then vanishes behind a building. A moment later, you notice another swoop, this time in the opposite direction. If you were to piece the motions together, both forward and backward, the bird's story might look like a small time loop, a curl in the fabric of motion. This is how one interpretation of particle behaviour works. A particle moving backward in time can be seen as a different particle moving forward. In the language of gentle imagery, it's like watching footprints on a beach and not being entirely sure whether a traveller walked toward the water or from it. The two interpretations describe the same pattern, just viewed from different angles. This perspective, soft and strange, helps us understand that time, especially at the smallest scales, is not the rigid command we often imagine. It behaves more like a suggestion, allowing brief, subtle divergences that enrich the universe rather than disrupt it. These divergences are not the dramatic rewinding of clocks or the grand loops of science fiction. They are whispers, small ripples that drift against the current before blending back into the flow. You've likely felt echoes of this softness in your own experience. Think of déjà vu, that brief tug in the mind where present and past overlap, where a moment feels like it's arriving for the second time even though you know it's the first. Or consider the way memories drift, reshaping themselves with each recollection so that a moment from years ago can return with a different colour or tone. Even the rhythm of your breathing can stretch or shrink your sense of time, slowing it during moments of calm, quickening it during moments of urgency. These are not quantum phenomena in the strict sense, but they quietly mirror the flexibility underlying the physical world. Time, at its most fundamental, is not a dictator, but a rhythm. And rhythms can change. They can pause, stretch, quicken, or even seem to rewind in the softest ways. Virtual particles borrow time and energy in tiny loops. Fields allow fluctuations that appear to ripple ahead of their causes. Certain particle paths can be described as curling backward before moving forward again. These illusions do not rewrite the universe. They simply remind us that the flow we experience as steady and linear is built atop a more delicate dance. To feel this dance intuitively, imagine holding a ribbon between your hands. You can stretch it out straight, smooth and flat, but you can also let it loosen, allowing gentle curves to form. The ribbon doesn't break, it doesn't resist. It simply reveals shapes that were always possible but unseen until you softened your grip. Time behaves in much the same way. The straight line is only one of the forms it can take. In this sense, cause and effect are not rigid blocks. They are stories, and stories can be told in different ways depending on where you choose to begin. Some events might feel as though they precede themselves, especially in the ephemeral world of quantum fluctuations. Others curl into loops that only make sense quietly, in the background of the universe's hum. These small temporal flexibilities are essential, not optional. Without them, the vacuum could not hum with energy. Without that hum, atoms could not form. Without atoms, the world as we know it, stars, oceans, voices, dreams, would never arise. Time's softness is not a flaw. It's a quiet gift, a slender thread woven into the fabric of being. As the meaning slowly folds itself into stillness, it invites us into a deeper understanding that moments do not simply march forward like soldiers. They swirl and weave, gently influenced by the subtle interactions beneath everything we touch. And from this swirling foundation arises the next curiosity, the way time can freeze under watchful eyes, paused by attention itself, waiting for stillness to break before continuing its flow. There is a moment familiar to anyone who has tended a garden. You lean in to check on a budding flower, watching closely to see if it has opened even a little since the last time you looked. And somehow, the more often you check, the less it seems to change. It's as if your attention is a kind of pause button, holding the growth in place. Only when you step away for a while, letting time breathe, do you return to discover that the bud has unfolded into something new? The quantum world contains a version of this very experience, one that's far more literal than metaphor. It is known in technical language as the quantum Zeno effect, but we can think of it much more gently as the tendency of a system to freeze when we repeatedly try to observe or verify what it is doing, not because observation is harsh, but because each act of looking interrupts the very process we're trying to witness. To ease into this idea, imagine a candle flame in a quiet room. The flame wavers softly, following its natural rhythm, brightening, dimming, swaying almost imperceptibly. Now imagine someone trying to take a photograph of the flame every fraction of a second, turning the room into a staccato burst of flashes. Flame still exists, but each burst of light disrupts its natural motion, forcing it to reset as though the flame must start its dance over again with every interruption. With enough flashes, the flame's motion becomes more hesitant, more brittle, almost frozen. The delicate continuity of its flicker breaks under constant inspection. Quantum particles behave similarly. Left alone, they evolve, from one possible state into another, from one configuration of probabilities into the next. They move like melodies drifting from one note to another, following the natural flow of their physics. But if we continually measure them, constantly asking, "Are you still in this state?" we interrupt that flow. Each measurement resets the system's evolution, pressing it back toward where it began. If the measurements come frequently enough, the system barely changes at all. It becomes pinned into place, unable to perform its natural transitions. This would be merely curious if it were not also deeply revealing. It tells us something profound about the relationship between observation and becoming. A quantum system does not simply exist in a state, it moves through possibilities, and observing it too insistently can freeze that movement, like someone interrupting a dancer's every step to check whether their foot is exactly where it ought to be. This soft freezing of evolution appears in everyday life as well, though not with the precision of particles. Consider a wound trying to heal. The body knows what to do, cells gather, weave, seal, strengthen. But if we constantly pick at the scab, checking whether the wound has healed yet, we interrupt the process, forcing it to start again and again. Healing requires trust, patience, and a willingness to let things unfold without constant interference. The same is true in relationships. Over-monitor something, a friendship, a romance, even a quiet bond formed over years, and it can begin to stiffen under the pressure. The natural rhythm of closeness and distance becomes fragile. Trust is replaced with watchfulness. The gentle motion that once guided the connection is repeatedly reset. The warmth cools. The dance becomes uncertain. Or think of a dream you're trying to analyze while still inside it. The moment you begin asking questions, why am I here? Is this real? What happens if I do this? The dream often dissolves. It cannot survive too much attention. It needs space, darkness, allowing, just as the quantum world needs room to evolve without interruption. The Zeno effect suggests something similar is true for time itself. When a quantum system is left in peace, its timeline is fluid, a continuous flow of transformation. But when inspected at too high a frequency, its timeline fractures into tiny resets, each one pulling reality back to its previous moment. Time becomes a series of stops and starts, like a heartbeat held back by too many checks. It's a reminder that even time must be allowed to breathe. Imagine standing on a quiet shore watching waves roll in. Each wave rises, crests, and falls. But if you were to interrupt the wave constantly, casting stones at it the moment it begins to rise, it would never reach its full shape. The ocean would remain restless but incomplete. In the same way, the universe's rhythms can hesitate under constant measurement. This idea might feel distant, but there is something deeply soothing about it. It tells us that the universe evolves through gentle openness, not through obsessive scrutiny. Change, whether in particles, people, or experiences, requires freedom. It needs moments where we let go, where we allow life to move without our constant checking. It needs space, quietness, and trust. And perhaps more subtly, the Zeno effect reveals that stillness is not always natural. It can be the result of too much attention. Sometimes we hold ourselves in place not because we are meant to stay there, but because we are watching ourselves too carefully, waiting for certainty, questioning every step, inspecting every movement. When we do this, our lives can feel stuck, even when the underlying possibilities are trying to flow forward. But the quantum world offers a gentle antidote. If you stop measuring a system so frequently, if you let the intervals between questions grow wider, the natural evolution resumes. Melodies reconnect, ripples return. The dancer takes a step. The timeline loosens its grip and starts to flow again. This invites us to soften our attention when needed, to let some things unfold quietly without pressing them for answers, to allow experiences the time they require, to trust that not everything needs to be observed in order to become real. Some changes grow best in the dark, like seeds beneath soil, or like dreams allowed to continue without being named too soon. And within this soft lesson, a deeper truth begins to appear. Time is not only something that carries us forward, but something that welcomes our willingness to step back and let it work. A river does not rush when we stare at it, it flows on its own. And sometimes the most profound shifts happen only when we stop watching long enough for the world to exhale. If you press your hand against a wall, you feel its firmness, the reassuring solidity that tells you where your world ends and something else begins. Walls define boundaries. They give shape and structure. They tell us, quite reliably, you cannot pass through this. And yet deep within the quiet machinery of the universe, particles slip through barriers every moment, barriers far thicker than themselves, barriers they seem to have no right to cross. This soft impossibility is called tunneling, but tonight we can think of it more gently, as the universe's reminder that boundaries are often thinner, softer, and more flexible than they appear. To feel the idea intuitively, imagine a fog drifting across a field. If you place a fence in the middle of that field, the fog doesn't stop. It doesn't turn around or gather itself into a tight shape. It simply seeps through the gaps, through the smallest openings, through any place where the boundary isn't completely absolute. A quantum particle behaves in much the same way. It is not a tiny ball trying to force its way through. It is a probability cloud, a soft smear of possibility. And part of that cloud can extend into regions the classical world would forbid. At the smallest scales, particles are described not as single points, but as waves of likelihood, like a candle scent drifting through a room. When such a wave encounters a barrier, it doesn't halt abruptly. It fades, like the tail end of a sigh. But if the barrier is thin enough, or if the wave is persistent enough, a small part of it leaks through, and on the other side of the barrier, the wave blossoms again, becoming a particle that appears where it statistically should not, like a whisper slipping through a closed door. This soft trespassing is not optional. It is woven into the processes that keep our world alive, the very fusion that fuels the sun. The gentle roaring warmth that lights days and stirs seasons depends on tunneling. Hydrogen atoms at the sun's core do not have enough energy to crash into each other and merge in the ordinary classical sense. They are too sluggish, too weighed down by the repulsion between their electric charges. Yet, through tunneling, they quietly slip through the energetic barriers that should keep them apart. They merge not through brute force, but through subtlety. The star that warms our world is powered by whispers, not collisions. To soften this further, imagine two people too shy to reach out and hold hands. They stand close, maybe sharing the same bench or leaning against the same fence, but their hesitation creates a kind of invisible wall between them. In the classical world, that wall would remain until one person musters the courage to cross it. But in the quantum world, shyness does not prevent connection. The boundary itself softens, possibility slides through. A moment of contact appears before it either consciously chooses it. This is the essence of tunneling, the idea that boundaries are not absolute but permeable in ways that defy simple intuition. And just as this principle shapes the sun, it shapes us as well. There are emotional boundaries we treat as walls, fears we don't cross, stories we do not revisit, opportunities we assume lie beyond our reach. But tunneling reminds us that these barriers are often made of thinner material than we think. Possibility can seep through. A small part of us, one that we don't always acknowledge, may already be on the other side before we consciously decide to move. We encounter moments of courage, insight, or connection that seem to come from nowhere. In truth, they slip quietly through the boundary we thought was solid. The softness of tunneling also challenges our notion of impossible. In daily life, we often divide outcomes into neat categories. This can happen, that cannot. This is reachable, that is out of bounds. But at the quantum level, there is no absolute line between allowed and forbidden. There is only a spectrum of possibility, some paths likely, others unlikely, but none completely erased. Even the walls of atoms themselves, those structures that define the rigidity of solid matter, are alive with tunneling events. Imagine a raindrop perched on a windowsill. For a while it seems as though the drop will stay exactly where it is. But then, with no visible change, it suddenly shifts, trickling down the glass. Something very similar happens inside the atoms of your body. Electrons tunnel between energy levels, rearranging the architecture of matter in ways that make chemistry possible. Without this quiet flexibility, the world would be frozen in a single arrangement forever, unable to evolve. And the more deeply we look, the more we realize that tunneling is not a rare event. It is constant, like the steady beating of a hidden heart. It happens in radioactive decay, when particles slip out of atomic nuclei. It happens in the nanoscopic switches inside computers, enabling the technology that shapes our lives. It even happens in the enzymes within your cells, helping reactions unfold at speeds that would be impossible otherwise. Each event is a reminder. The universe is not confined by the rigid boundaries we imagine. It works through gentle persistence, allowing possibility to seep into places where certainty would say, no. This gentle lesson carries a quiet invitation. When you encounter a boundary in your own life, an idea that feels out of reach, a hope that seems blocked, a fear that insists you cannot move forward, you might recall that even the smallest particles are not held fully captive by their constraints. They find ways to slip through, not by force, but by allowing their inherent softness to guide them. They rely not on breaking barriers, but on discovering the spaces where possibility quietly gathers. In this way, tunneling becomes more than a physical principle. It becomes a metaphor for resilience, for subtle courage, for the quiet ways we navigate walls that seem too heavy to climb. It reminds us that not every path must be walked directly. Some paths are entered through overflow, through patience, through the willingness to let our potential seep into new spaces before we fully understand the journey. As this thought settles, it gently opens the way for our next exploration. The idea that particles don't simply follow single paths at all, but move through every path they could take, each possibility adding its own note to the symphony of reality. If you've ever watched a traveller trace lines across a map, eyes wandering from one road to another, fingers gliding along valleys and rivers, you've seen a hint of how the quantum world moves. Before the traveller chooses a route, the journey exists in a kind of soft limbo. Many possible paths, each with its own scenery, its own moments, its own stories waiting quietly in the folds of paper. Nothing has been decided yet. The world for the traveller is a branching landscape of potential. At the quantum level, particles behave with a similar openness, but in a way that is even more astonishing. When an electron moves from one place to another, it does not pick a single path ahead of time. It spreads into every possible route at once, every curve, every crossing, every diversion. It explores all of them as softly as fog exploring a forest, brushing against every tree, flowing through every clearing, slipping into every space where air allows it to drift. Physicists describe this using something called a path integral, but tonight we can imagine something far gentler, a particle as a traveller who considers every trail simultaneously, weighing each one not with conscious thought, but with the natural rhythms of the universe. Each possible path adds its own faint note to the music that ultimately shapes where the particle appears. Instead of choosing a single melody, the particle listens to an orchestra of possibilities, and the outcome, the place where the particle finally shows up, is like a note that rises from this orchestra when all the other sounds have woven themselves into harmony or cancelled one another into silence. The music of all possible paths leads to a single, tangible moment, not because the particle made a rigid choice, but because the universe held a quiet conversation among countless options and allowed one to emerge. To soften this further, imagine a flock of birds wheeling across the evening sky. Each bird follows its own motion, dipping and gliding, yet when you step back and watch, the entire flock moves as though it is one flowing creature. Patterns emerge from the gentle sum of many individual motions, a shape that no single bird intends, but all participate in. A quantum particle behaves similarly. Its final path is an emergent shape, drawn not from a single choice, but from a vast chorus of tiny contributions. Even in our lives we can sense moments like this. Before we make a major decision, where to live, whom to love, which future to pursue, our minds wander through possibilities. We imagine one route, then another. We try on alternate versions of ourselves, like outfits hung on the rack of imagination. Sometimes we get lost in the branching forest of choice, unsure which direction is best. And yet, when the moment comes, a decision forms, a path ripens and becomes real. The others do not vanish. They simply fade into the background, their notes still humming quietly beneath the story we ultimately live. Those unchosen futures are like quantum paths that cancel quietly, leaving only the melody that reaches our present. Another way to feel this is to picture a stone thrown into a lake. Countless ripples spread outward, overlapping, merging and interfering in beautiful patterns. Some waves build each other up, others soften into stillness. When all is done, the surface finds a shape that reflects the sum of all those interactions. A particle's journey is much like this, its many possible paths forming a kind of ripple pattern, an interference of potentials that gives rise to a single outcome. This strange, soft multiplicity suggests something profound. The universe doesn't operate by eliminating possibilities. It operates by weaving them together. Even when a particle ends up in one place rather than another, that final position is the result of every path it could have taken. Its presence carries the memory of all its might-have-beens. There is comfort in this idea. Too often we imagine our lives as a single file of moments, each one pushing the next in a straight line. But beneath that simplicity lies a richer truth. Before each step we take, there is a symphony of potential steps, a quiet orchestra of choices we consider, emotions we weigh, dreams we rehearse, and fears we hold. The path we choose is shaped by the interference of all these possible futures, and just as a particle's path is influenced by the environment, by fields, by forces, by hidden currents, our own decisions are shaped by countless subtleties. A conversation that lingers in memory, a kindness offered by a stranger, a thought that drifts into mind at just the right moment. None of these things determine where we end up, but they influence the symphony that plays inside us, nudging some paths forward while quieting others. This view also softens our relationship with regret. In the quantum picture, the path not taken still played a role. It shaped the interference pattern that led to this moment. Your unchosen futures, your alternate selves, your what-ifs and nearly would-haves are not meaningless ghosts. They help sculpt the shape of your present life, just as untravelled quantum paths sculpt the final behaviour of a particle. You do not become who you are by a single choice alone, but by the entire landscape of choices you walked among, even those you ultimately left behind. In this sense, we are all travellers in a many-path world, moving through possibilities that whisper to us before condensing into moments. And when we pause long enough to listen, we might sense the faint music of those paths, the lives we did not take but still carry within us. As the idea comes to rest like a leaf on calm water, it gently leads us toward another delicate truth, that the universe doesn't just weave many paths into a single outcome. It also hides entire worlds of possibility behind the choices we make, like fog that gathers before falling softly into rain. If you picture a fog drifting across a valley at dawn, you'll see a landscape that is both present and hidden. The hills are there, yet softened. The trees are there, yet blurred. You sense the world beneath the mist, but its edges have not committed to a single shape. This is a gentle way to imagine what physicists call superposition, the state in which a quantum system holds many possibilities at once, like a fog of outcomes waiting for a question to bring one of them into focus. At the smallest scales, particles don't sit in one precise location or hold one definite identity. They drift between possible states, multiple positions, multiple orientations, multiple futures, layered quietly on top of one another. A particle in superposition is not confused or indecisive. It is simply free to explore every allowed configuration before the universe asks it to settle. Free to hold many options without committing. Free to wait for the soft nudge of observation to choose a path. When a measurement is made, something remarkable happens. The fog clears. All the overlapping possibilities fade away, like mist becoming a single raindrop. The particle snaps into a definite state, not through force, but through the gentle touch of interaction. This moment is often described as wave function collapse, but we can think of it instead as a choice, the universe's way of saying, of all the paths you could take, this is the one that becomes real. This doesn't mean the other possibilities vanish into emptiness. They retreat into silence, becoming part of the hidden scaffolding that shaped the final outcome. Much like a dream that dissolves when you wake, but still leaves behind a feeling, a mood, a faint echo of what might have been. To soften this further, imagine a musician improvising. Before they choose the next note, a cloud of musical possibilities surrounds them. They might drift upward into a bright phrase, or slide downward into something tender. When their finger presses the string, or their breath shapes the next sound, one note becomes real. But the beauty of the performance is shaped partly by the notes they didn't choose, the silent companions that gave the chosen note its meaning. Possibility gives birth to presence. Some interpretations of quantum physics take this idea even further, suggesting that every possibility becomes real, not just the one we witness. In these views, often called many worlds, every potential outcome grows into its own branch of reality, like countless rivers flowing away from a single spring. In one branch, a particle turns left. In another, it turns right. In yet another, it drifts somewhere quietly in between. None of the branches erase the others. They coexist, woven into a cosmic tapestry far larger than anything we can see. Whether or not these parallel worlds exist as literal universes, the image offers something emotionally resonant. It suggests that the choices you don't take are not failures. They are simply paths that continue somewhere beyond your view. shaping the possibilities that remain available to you. A gentle reminder that life is not a narrow hallway but a vast landscape, rich with unseen trails. Another interpretation, rooted in decoherence, suggests that the world splits not into separate universes, but into separate patterns, like branches of a tree that grow close together yet never touch again. When a system interacts with its environment, the delicate superposition becomes entangled with countless surrounding vibrations, creating distinct, non-overlapping outcomes. You could think of this as the universe gently guiding possibilities into quiet separation, allowing each to form its own coherent story. This perspective feels more organic, like a garden growing in multiple directions at once. Some branches bear fruit, others extend into shade, some twist unpredictably. Each branch belongs to the same tree, yet follows its own trajectory. There is a third way of understanding superposition, one that is less concerned with splitting worlds and more concerned with our own limitations. In this view, the quantum system holds all possibilities until we ask a question that is precise enough to extract one answer. The collapse isn't a physical event, it's a moment of clarification, like focusing a camera lens on a single detail in a bustling scene. Everything else is still there, just not in a form we can capture. It's as if the universe always had a definite path, but we could not see it until we illuminated it with a specific kind of attention. Each of these ways of understanding superposition, multiple worlds, separated branches, hidden definiteness, offers its own insight. None is proven. All are attempts to make sense of the quiet, shimmering ambiguity beneath the surface of reality. But they share one thing, the idea that possibility is fundamental. Choices, outcomes, events. They are not rigidly pre-written. They emerge from a spaciousness that allows for many stories, even if only one becomes visible to us. This idea carries a soft emotional truth as well. The choices we make shape our lives, but the ones we don't make are not meaningless. They shape us too, by contrast, by influence, by potential. Every chosen path carries with it the echoes of unchosen ones. Like a raindrop formed from fog, we are shaped by the diffuse possibilities that surround us even as we solidify into a single moment. In moments of regret, it can be tempting to imagine that choosing differently would lead to a better version of ourselves. But quantum thinking offers a gentler perspective. The choices you didn't make are not lost. They simply reside in the quiet background of who you are, the way unplayed notes shape the meaning of a melody. They help define your direction even without becoming real in the physical sense. And when you imagine the future, you stand again in superposition, the fog of many possibilities swirling around you. Each one is alive until you choose. Each one holds its own quiet promise. You do not need to rush. You do not need to choose prematurely. The fog will clear when it is ready, revealing the next step with the same softness that guides particles into place. As this insight drifts into the quiet part of your mind, it gently prepares us to explore something even more personal. The way identity itself emerges from patterns, interactions, and probabilities, less like a solid object, and more like a song that rewrites itself each time you listen. If you sit quietly for a moment, long enough for the room around you to soften, long enough for your thoughts to drift into a gentle rhythm, you might begin to sense something subtle about yourself. Not the kind of truth that announces itself loudly, but something quieter, something that unfolds like a slowly blooming flower. You might feel the edges of who you are begin to blur, your memories, emotions, habits, hopes. They don't sit in neat compartments. They blend, they shift, they flow into one another. And in that softness, a realization begins to appear. You are less a fixed object and more a living pattern. The quantum world offers a surprisingly fitting mirror for this experience. At the smallest scales, particles are not tiny solid marbles. They are patterns of probability, shimmering tendencies to exist here or there, to spin this way or that. to adopt one possible configuration or another depending on the interactions that touch them. Their identities are not inherent. They emerge from relationships, from contact, from context. The universe doesn't hand them a script. It gives them a field of possibility, and they become real only when they meet the world around them. In the same way, human identity is not a static core buried deep within consciousness. It is an ever-unfolding pattern that emerges from the interactions between your biology, your experiences, the people who shape your days, the memories you revisit, and even the thoughts that drift across your awareness like soft currents of wind. Who you are is not etched in stone, it is woven in time. To feel this more intimately, imagine your consciousness as a hall full of mirrors. Each memory reflects another. Each emotion sends ripples through the reflections. Each interaction, from childhood to this very moment, changes the tilt of the mirrors, shifting what they show back to you. If you change just one mirror, even slightly, the entire hall transforms. That is how the quantum self behaves. It is not made of pieces but of relationships. Alter the relationships and the self reshapes. In physics, a particle's behavior is determined by the ways it interacts with other particles and fields. It doesn't carry a fixed identity that it presents to the universe. Instead, it responds to what touches it. Its spin, its momentum, its position. These appear only when something else asks the question. Without interaction, its nature remains open, fluid, unnamed. Humans are like this too. Ask someone who they are at work, and they give you one answer. Ask who they are when they are alone at night, and you receive another. Ask who they are when they love, when they fear, when they dream, when they lose something precious. And each answer emerges from a different interaction. We often imagine this means we are inconsistent, but the quantum view tells a gentler story. We are not inconsistent. We are responsive. We are relational. Our identity is not a statue. It is a song. And like any song, it changes each time it is played. Think of a melody that you return to throughout your life. When you hear it as a child, it fills you with excitement or innocence. When you hear it years later, it awakens nostalgia or longing. The notes haven't changed, but you have. The listener is part of the music. Likewise, your memories are not fixed recordings. They shift with context. They adapt to your current emotions. They take on new shades as you reinterpret them. Just as particle states form through measurement, your memories form through recollection. Every time you revisit them, they evolve. This is not a flaw. It is a quiet gift. It means your past is not a rigid chain holding you in place. It is a soft landscape that shifts as you grow, making room for healing, understanding, and new meaning. The brain itself behaves in patterns that echo quantum softness. Neural networks fire not in strict mechanical sequences, but in fluid waves of activation. Patterns that strengthen, dissolve, reconnect, and reshape themselves depending on what you experience. Even though the brain is not literally in a quantum superposition at the scale of neurons, the structure of its behavior reflects the same spirit. Identity is not a fixed point, but a dance of probabilities, rhythms, and relational states. You are an emergent pattern, like ripples formed from multiple raindrops landing in the same pond. No single raindrop defines the ripple. It is the combination that matters. The timing, the spacing, the strength, the background currents, the wind on the surface, even the shape of the pond. Identity emerges from the interplay of all these influences. Our lives mirror this emergence as well. A single conversation can shift the trajectory of a year. A quiet realization can reshape a belief. A moment of kindness from a stranger can soften a hard memory. A painful experience can deepen your capacity for understanding. Just as particles settle into states depending on the questions posed to them, we settle into patterns based on the experiences that touch us. This means that who you are is not a trapped essence, nor a rigid structure you must hold on to. You're a pattern that continually reorganizes itself, a moment in motion, a configuration of possibilities that settles just long enough to feel familiar before shifting gently again. There is comfort in this. It means you're not required to be a fixed version of yourself. You're allowed to change as the world changes around you, allowed to respond to new experiences, allowed to become softer or stronger or more open or more thoughtful without needing to justify the change. You are a ripple in a vast field of relationships, not a stone etched with unchanging words. And just as quantum patterns become clearer when observed with gentleness rather than force, ourselves reveal their truth when held with kindness. If you try too hard to define yourself, to pin down every detail, to force a strict identity, you may freeze the pattern, limiting who you can become. But if you allow yourself the softness of curiosity, the space to breathe, the freedom to shift, then your identity unfolds like a melody finding its next note. As this thought drifts to rest, it opens a gentle path toward a deeper idea, that uniqueness itself arises from the impossibility of perfect copying, that no pattern, not in physics nor in life, can ever be replicated exactly. And hidden within that impossibility lies one of the universe's most tender gifts. If you imagine holding a snowflake on your fingertip, you'll notice something delicate about it. Its shape is precise, yet impossible to duplicate exactly. Its pattern emerges from countless tiny interactions, air currents, temperature shifts, the faintest trembles of moisture in the air. Even if you stood beside a storm and tried to catch two identical flakes, you would never succeed. The universe, it seems, does not repeat itself perfectly. Instead, it favours uniqueness. Small variations, subtle differences, stories told only once. In the quantum world, this preference for uniqueness becomes a principle. There exists a quiet rule, sometimes called the no-cloning theorem, which simply means that no unknown quantum state can be copied precisely. But rather than approaching it with equations, we can soften the idea. In the smallest corners of reality, no pattern can be replicated without changing the pattern itself. Information at its most fundamental level is singular. Once you touch it, it shifts. Once you try to duplicate it, it becomes something new. This is not a failure of technology or imagination. It is the universe's way of protecting individuality. Quantum patterns cannot be photocopied. Their subtleties cannot be pressed onto a second sheet of reality without being altered. Much like emotions, moments, or memories, each quantum state exists once, in one place, in one shape, before dissolving or evolving into something else. If you think about your own life, you might feel echoes of this. Consider a moment that mattered deeply to you, a conversation, a realization, a sunset that arrived at just the right time. You could try to recreate it. You could visit the same place, say the same words, stand under the same sky, but the moment would be different. Perhaps softer, perhaps heavier, perhaps flavoured by who you have become since then. The memory of the moment is held gently in your mind, but the moment itself cannot return unchanged. That impossibility is not a flaw. It is what gives the moment its meaning. In quantum physics, the impossibility of perfect copying arises because observing or interacting with a state inevitably alters it. You cannot know every delicate detail without influencing the shape of the pattern you're trying to preserve. In everyday life, the same quiet truth holds. Understanding something changes it. Understanding someone changes your relationship with them. Understanding yourself alters the way you move through the world. Knowledge doesn't preserve, it transforms. So too does experience. A memory revisited will not feel identical to the first time it formed. The act of remembering reshapes it, folding new layers into its meaning. A friendship revisited years later carries the echoes of who you were and the imprint of who you've become. Even your laughter changes with time, once light, perhaps now deeper, carrying the resonance of everything you've survived. This mirrors the quantum behavior of particles that cannot return to a previous state without carrying traces of the journey they have taken. They evolve. They remember, not through conscious thought, but through the shape they acquire as they move through interactions. You are no different. The person you were at 10, at 15, at 20, still lives inside you, but only as echoes, their patterns softened by everything that has touched you since. There is a gentle part of this rule that often gets overlooked. The impossibility of copying is what makes connection meaningful. Because no moment can repeat, each one becomes precious. Because no conversation can be duplicated, each one becomes alive. Because no person can be reproduced exactly, not even a past version of yourself, each identity becomes irreplaceable. Uniqueness is not a rare accident. It is the default state of the universe. Even the simplest quantum entities carry a signature that cannot be cloned. A single particle, if prepared in a state you don't fully know, is like a poem written in a language you can read only partially. You may understand its rhythm, you may sense its tone, but you cannot rewrite it word for word without altering it. This is how nature embeds individuality into the very architecture of reality. And when we look at consciousness through this lens, something beautiful emerges. Consciousness is not a fixed point of awareness trapped in your mind. It is a process, a gentle unfolding of perception, memory, attention, and possibility. It draws from the past but never repeats it exactly. It encounters the present but never sees it the same way twice. It shapes the future but never in precisely predictable steps. Like a ripple on water, it is defined not by its permanence but by its movement. If you imagine your awareness as a playwright, softly shaping reality through the questions you ask, the meanings you assign, the things you choose to notice, then your uniqueness becomes inseparable from the story you create. And the limits that the universe imposes, not being able to copy perfectly, not being able to know everything at once, not being able to freeze time or predict every outcome, become gentle guides rather than harsh constraints. Limits teach us that we do not need to be infinite to be meaningful. They show us that imperfection is not a shortcoming but a signature. They remind us that moments matter because they cannot be repeated, that relationships matter because they cannot be duplicated, that you matter because no version of you, past, present, or possible, can be replaced by another. We often imagine that perfection lies in control, knowing everything, predicting everything, copying everything. But the quantum world offers a softer wisdom. Perfection lies in presence, in being unrepeatable, in being here in this moment, shaped by everything that has touched you and everything that will follow. And as this thought settles into stillness, the final message begins to take shape, as fragile and luminous as a firefly's glow in the darkness. You're not separate from the universe watching you sleep. You are one of its waves, folding inward, settling for the night. The uniqueness you carry is not a burden, nor something to prove. It is the quiet way the universe expresses itself through you, a pattern that will never appear again in exactly the same form and does not need to.